Hello everyone, my name is Kgoboko and I'm with Thabo to present to you about integrating high resolution images and machine learning for population prediction in an informal settlements. Next please. The biggest issue that you have with the challenge of not being able to know population of an informal settlement is you end up with government and planning institutions not being able to plan and to give like the right resource allocations for those areas. Next please. So we had the two data sets we had a high resolution image and we had survey data where people go door to door counting the people that live in that area. Cool. And then so what we did in this case is that we used QGIS to slice the high resolution image into digestible pieces that we can feed into machine learning. Then we use CVET to basically annotate the images into dwellings for which ones we want the model to focus on, a fine-tuned segment anything model for dwelling extraction, and finally a Bayesian regression model for population estimation. Cool. Yeah. Finally, then we got to a point where you can see an image, the pictures of the different dwellings, how many houses live in that area, and the population for that specific house. Cool. And then we did like a visualization, a Power BI dashboard to track our training, our splits, our images, and how basically our model performs, and finally how the segmentation model works with the original image mask and the overlay.
Okay, I'll now handle the demo of the deliverables. There were two types of deliverables that we made. One that focused strictly on the segmentation anything model, where we took an original image, a mask, and the overlay and trained the model, and it was fine-tuned on 12 images which contained about 232 annotations. Over here you can see two deployment models, one with a strict focus on the segment anything model. For the sake of time, we're going to start segmenting while speaking on the application. As you can see, each application gives you different intervals and settings that you can use to manipulate, even for technical and non-technical users, to use these models. We did this to allow both people without a coding background or with a coding background to be able to use the software and also navigate which filters would work best. While they're running, I can also kind of go over the performance. So our segment anything model performed quite well. With the main metric we want to look at is the mean dice coefficient, which is a metric that is used to rate both natural language processing projects as well as segmentation models. And our model was able to evaluate at a 94.3% accuracy, as well as a high precision and recall on extracting the ground truth and comparing it to what we were able to capture in CVAT. Then the Bayesian regression model, if we look at this model, it struggled a bit more, but this was due to limitations in our data, right? And we evaluated three different models, one which is an area-only multi-feature model and a multi-feature with a horseshoe. As you can see, based on the mean average error and root mean squared error, our multi-feature with horseshoe regularization model was our best performing model. But due to the limitations that I've written here, of basically the area that we're trying to view and amount of buildings and allocations of population per building, there was a restriction. Our client is aware of this, and there is a more refined database, but due to Popia, we do not have access to that. If we now go back to our images that we rendered, we can see here that this is how our model performed in basically segmenting the building features. And as you can see, due to its me adjusting certain parameters here, it will perform differently. But it captured most of the buildings, but also captured other items that weren't there, such as cars. In our other application, it's a bit more refined as we use predetermined parameters that we choose that are best, and it extracts all the building features, but as well as the other features on the ground, and will tell you how many detected, as well as a range on the population. We also do stipulate the mean error that we have. The reason why we use a range is because of the inaccuracies that are highlighted in the slides. In conclusion, the segment anything fine-tuned model effectively extracts building footprints in dense informal settlements with high accuracy levels. The Bayesian regression model showed great potential for predictive power, but low accuracy due to the limitations of labeled data. Thank you.